Alright, so now we're looking at 1.2. So we're going to be trying to use Venn diagrams to help us organize sets and then maybe even solve some problems. So here's an example. So let's say that someone asked their class of 30 which sport they like, and these were the results. So 17 liked hockey, 10 liked basketball, and 9 liked neither. So I've got some questions here, but before I even look at the questions, I start drawing my Venn diagram. Okay, so I've got a universal set would be the 30 people that are in the class. Okay, I've got hockey, basketball, and I'll probably have some people that like both. So I usually draw it as if there are some people that like both. And if it comes out that there are no people that like both, that's okay. We can just account for that at the end. For now, though, we can say that hockey and the basketball looks something like this, right? Where there's an overlap where some people like both, which is probable. Alright, so what I usually start with is the neither. So I know that 9 people like neither one of these. So I know that outside of these two circles, I've actually got 9 people over here. So 9 elements are not in H, neither are they in B. Alright, so now I've got 10 people that like basketball. So that means that inside of set B is right here, I've got 10 people, right? So that counts. This area right here, the people that only like basketball are right here. And this area right here is the people that like basketball and hockey, right? So this number 10 represents all of this area right here. Okay? Now, likewise, this number 17 represents all the elements that are inside of H. Okay? So I've got 17 people inside of set H. Alright? So I don't know how many people are inside of both circles, though. So how many people like both sports here. Alright? So what I'm going to do is I'm actually going to call that X. Okay? You might find that hard to see, so I'm actually going to redraw what I have here. Okay? So the number of elements that are inside of both of these sets, I don't know, so I will call X. So however many people are there. Well, remember I've got 10 people that like basketball, right? So inside of set B here, there are 10 people. Well, there are some of them here. I don't know how many are there exactly, but if I did know how many were here, I could easily find out how many were out here, right? So let's say if X here was 3, I don't know that it is, but let's say it was, then I could easily find out that if there are 10 people in B, and 3 of them are here, that this must be 7 out here, right? Or if there are 4 people right here, then the other 6 must be out here, right? To make up the 10 that are in set B. So I know that the number of people that are out here will really be the number of people that like basketball minus the number of people that also like hockey. So I can say that outside of, or in B, but not in H, would be the number 10, the number of people that like basketball. Take away how many people are right here, so in this piece here, right? Because I know that these two pieces should add up to 10. Likewise, hockey adds up to 17 people, so inside of set H I've got 17 people. Well, if I've got some of them here, then the rest of them must be out here, right? So this here would be 17 minus X. Of course, we've also got our 9 out here. So now what I have here is a Venn diagram that's completely filled out. I've got all 4 sections, 1, 2, 3, 4, and I know that 30 people were surveyed. So I know now that all of these pieces should add up to 30. So I can say that the first section, so 17 minus X, plus the second section plus X, plus the third section plus 10 minus X, plus the piece out here plus the 9, don't forget about this piece here, should equal the 30 people that were surveyed. Okay? So now it's just a little bit of algebra to solve for the missing value. So what I usually do first here is I notice that I've got a negative x right here and a positive x right here. So negative x plus x, well, they actually cancel each other out because negative x plus x is 0. Negative 1 plus 1 is 0, right? So these cancel out, leaving me, when it comes to x terms, just this guy right here, just minus x. So I'll write down my negative x here. Now what I'm going to do is add up my like terms right here, my constants. So my 17 plus my 10 is 27, plus my 9 is 36. So I've got negative x plus 36 equals 30. Okay? So now I go to solve for x, so I need to isolate the variable. I need to get x all alone, so I need to get rid of the 36 that's here. This is plus 36, so to get rid of addition, I do the opposite. The opposite of addition is subtraction, so I'm going to subtract 36 from both sides of the equal sign. 36 minus 36 right here is 0. That cancels it off on that side of the equation, giving me negative x equals 30 minus 36 is a negative 6. Okay? So I know that negative x is equal to negative 6, but I want to know what positive x is. So I can kind of envision this as a negative 1x if I wish. So if I want to solve for positive x, I need to get rid of the negative 1 that's multiplied by the x. So to get rid of multiplication by negative 1, I do the opposite. The opposite of multiplying by negative 1 is dividing by negative 1. So I'm going to divide this side of the equation by negative 1. Of course, negative 1 divided by negative 1 now gives me a positive x. Of course, what I do to one side of the equation, I also need to do to the other side of the equation. So I divide this side by negative 1 as well. Negative 6 divided by negative 1 is a positive 6. So that tells me that there are 6 people that like both hockey and soccer. Okay? Now B is how many people like hockey but not basketball? Sorry, hockey and basketball. How many people like hockey but not basketball? Well, I know that 17 people liked hockey in total. 6 of them are right here. So that must mean the rest of the 17 would only like hockey. So that would just be 17 minus 6 then, which would just be 11 people that only like hockey. Okay, so 17 minus the 6, which is 11. How many people like basketball but not hockey? Well, I know that 10 people like basketball in total. Well, if 6 of them also like hockey, well, that must mean that the rest of them like basketball but not hockey, so 4. Okay?